I am Fitria from ITS Global Engagement and will be your Master of Ceremony this afternoon. Thank you for joining our guest lecture series today. Before we start our agenda, let me inform you about the webinar protocol. First, please adjust your name or ID screen using format department_your name. Second, during the lecture, please turn on mute mode and only turn on the audio when the moderator gives the chance. Third, please fill your attendance at bit.ly/attendance_GLSDEPT. Our committee also sent the attendance link in the Zoom chat room. And the last is participants who wish to ask questions during the question and answer session. Please send your question to bit.ly/question_GLSDEPT. The link for questions list in the chat room too. Or you can ask directly by clicking the raise hand feature. Ladies and gentlemen, committed to strengthen international partnership and to provide a world-class learning environment, Institut Teknologi 10 November, Surabaya is inviting materials and metallurgical engineering students to enjoy world-class lectures delivered by world's best lecturers through guest lecture series on department. And today's theme is Waste to Wealth, Biowaste into Valuable Polymeric Materials, which will be delivered by our speaker, Associate Professor Dr. Hakimah binti Osman from University Malaysia Perlis. And the lecture will be moderated by Amaliya Rasyida, ST M.Sc from ITS. Yeah, welcome Professor Hakimah and Bu Amaliya.
Yeah, thank you.
Yeah, okay. Before we proceed to the next agenda, allow me to deliver our schedule today as follow. First, lecture. Second, question and answer session. Third, certificate awarding. And fourth, closing. Okay, before we go to the first agenda, let me introduce our moderator. Yeah. Okay, our moderator today is Bu Amaliya Rasyida from Institut Teknologi 10 November. She is an instructor lecturer at Materials and Metallurgical Engineering Department and also member of Innovation Materials Laboratory. And about her education, she has finished her study in Materials and Metallurgical Engineering Department, ITS Surabaya for bachelor degree. And for master degree, she has studied in Materials Science and Engineering and UST. And about her expertise is in polymeric and composite for biomedical application. And some of her research collaborations are PBAT-based nanocomposite with NTUST Taiwan and injectable biomaterial for NP replacement with Department of Neurosurgery or Dr. Sutomo General Academic Hospital. Yeah, okay. Without further ado, let's proceed to the main agenda. To Bu Amaliya, the time is yours.
Yeah, thank you, Mbak Fitria. Okay, hello everyone. Assalamualaikum. I am Amaliya, lecturer from Materials and Metallurgical Engineering Department. I would like to say thank you very much for your preparing to join this guest lecture series. And also I would like to thank you to International Office of ITS for facilitating this guest lecture series. So welcome to this guest lecture series department-based. Today's lecture is titled Waste to Wealth, Biowaste into Valuable Polymeric Materials. I think this is a very interesting topic. And then before we begin, let me give you a quick review of overview of these lectures. So the presentation will take approximately 50 minutes and it allows us also to have a question and answer at the end of the session. And now I think we can introduce our honorable speakers. Welcome, Professor Hakimah Osman. Thank you, and Alhamdulillah we can meet here.
Thank you. Assalamualaikum semua.
Yeah,
Good afternoon.
Let us give a warm welcome to Professor Hakimah Osman. So, Professor Hakimah Osman finished his doctoral study in Polymer Engineering University Science in Malaysia, and also she took his Master Science in Polymer Engineering as well in University Science Malaysia, and also he take the Bachelor of Industrial Technology in Polymer Technology University Science of Malaysia. So by seeing this education, so we believe that she is an expert in polymeric materials, right?
We are the same. Thank you for the opening.
And furthermore, she is also awardee in some of awards, such as L'Oreal Award for Women, and also she is best of the best in Asia Invention Cup, and also she is awardee in the World Inventor Award Festival 2013, and up to now she is the associate professor at the School of Materials Engineering. And then his skill is, yeah, we know she is an expert in a polymeric, so the skill is a polymeric research field, and also engineering educator and top researcher, and I see he has a very good research with the some publication and also high level citation and also high citation in his paper. Yeah, okay, so let's invite Professor Hakimah Osman to deliver the talk. Professor Hakimah Osman, please.
Thank you, Bu Amaliya. I think it's a long introduction. Thank you so much. And thank you for ITS for inviting me for the guest lecture series. Okay, and honestly, this is my first time giving lectures for Indonesia University. So I feel blessed and very thankful to the organizer. Okay, without delay, let me start my presentation and let me share my slides. Okay. Yeah. Okay, so just now, Bu Amaliya have said that I'm from School of Material, but actually we have, rebrand into one big faculty. It's a faculty of Chemical Engineering Technology. So yeah, so now polymer is under that faculty. So later on, when you go into our website, so please go to the Faculty of Chemical Engineering Technology. So my topic today, okay. Why I choose this topic? Because like we know, it's like become a versatile topic that chosen by many of researchers in the world because of one has demands for the from the industry to move forward into something more sustainable. Okay, and then one more thing in terms of the environmental factors, we have a lot of bio waste. So it's time to to do something on it by convert it into a valuable product. It's not only on polymer materials, but also related to it. We have like 48 slides, but I try to move fast. And yeah, you can take note on any slide that you want to ask me after this. So actually if you read from any books, journal, or any reference, certain people in different fields will look at the biomass and biomaterial, bio-waste, different terminology. But for me, after from my readings and my experience in doing this research and also teaching the subjects, Actually, bio waste is a subset to the biomass. Biomass is more, more familiar to those in the chemical engineering, bioprocess. So for polymeric materials, expert or researchers in this field, we are more familiar with the bio waste. So I think most of you agree with me. So in the big scope, actually, but we can have a bio waste directly produced, from the plants or animal. So it is a organic material derived from the plants or animal. And from that, actually, when we process the bio waste itself, it will produce a byproduct. So the byproduct later on can be further converted into another product. So that's why it has two ways to utilize the bio waste here. And in another aspect also, bio waste is divided into two, wood and non-woods. So I think most of you are familiar with what is wood is and what is non-wood is. So non-wood is such as proteins, wood is cellulose. Okay, so we straight go to the bio waste. There's a lot of reference refer to different classification, but you can stick on one terminology based on your understanding. Actually, dia tak lari lah. It's not not so much different as long as like what is the food waste, what the human animal waste, green waste and brown waste. So as long as you can differentiate this, so you are at the right track. And for me, I am more work with the green waste, brown waste for now. So from my colleague also work with the food waste for maybe for other utilization such as fertilizer. Okay, human animal waste such as, have you heard about people use the chicken feather for composite in for certain application. Okay, we go to the food waste because food, without we know, actually we have produced about more than 4,000, almost 4,000 tons waste for foods only. This is from the sekolah kan. So the waste can come from whether after we eat, after we process the food, or even something that left over from the racks kan, from the supermarket near racks too. So it's considered as food waste. So what we can do with this food waste? And next is a green waste. So the green waste is actually is not is a classification. Is classified also this like fruits also, but it's a more on the green what we call it the after harvesting the things, harvesting the any crops. And then brown waste, okay, you can see here, and more on the the percentage of the where it come from. All the source I cited from the Malaysia researchers lah, because it more closer to you to understand how big is the problem we face about the bio waste. Okay, so I believe okay, when we talk about the bio waste research or any research, we must always look into the real problem or the real, and then the problem must come into the real problem solving. So only we can make our research valuable in terms for the community, industry, for the institution itself, and also what else? For the environment. So this one, I suggest that for those, even not only for undergraduate, or maybe later you are going for work or further your study. So whatever you want to do, so you must have a target. Actually, what is your agenda? So it does it can be one or two, not necessarily one agenda on this. I mean the SDG goals. Maybe like by using the bio waste, so you can reduce the climate change, and at the same time, because you are creating new industrial sector, economic sector, so you are actually reduce the poverty in Malaysia or even in the world. Okay, this I think very if anyone familiar with this, actually our research must be very dynamic in terms of it must cater, all, we call it the quadruple helix, meaning that if you have one research under your institution, so like myself under UniMAP, your research actually must be close to the to serve the of course the academic research, in terms of you are producing the PhD, masters, or even undergraduates, and at the same time some research linking with the industry, so it's open to the commercialization. And not to forget is to the society. Now we have also research where actually more towards the society. So in Malaysia, we have kind of the research actually, offer to like improve the economic sector of the society nearby. Okay, what I always believe in research is, okay, when we are talking about research, okay, I don't want to make or undergraduates like, this presentation is more like suitable for, for people like me or postgraduate students. No, now it's time for you to aim, even for your final year project, what you want to do for your final project, at least. So actually, of course, you must know what you are going to do. Or if your project can come with the products, so you can look at this, I call it a criteria of product towards commercialization. So for me, the most important, you must know what type of bio waste you want to work with, to develop, to produce a polymer product. And then later on, the process, what the process behind that, and then related to that, this 4M must be highly considered: money, man, machine, and market. Okay, this when we talk to any industrial people, so most probably these 4Ms is their main core business. Okay, after you know what you want to produce or you want to do for your research, okay, this is, we call it the product development. You start with the material choice. So we are material expert. We must know what type of polymer is suitable for what bio waste we want to use. Because we know that bio waste is a hydrophilic. Okay, so for the synthetic polymer is a hydrophobic. And you know what to make these two material to be compatible. Jadi the study needs to be started and what we call carefully selected for the materials. Okay, if you choose wrong material, so all this like, scrap, you have to start all over again. So these two criteria, these two charts actually is, will be in my books later, like in my books chapter. So this from the reference from my readings. Okay, I like to, before we go further, there is, the most common things that you need to know when you deal with the bio-waste. So, bio-waste is not only abundant, and actually it's free source. And now, not lately because we have to look at we open the new economic sector to the society. So we call it, we have to create some tokens for them lah, for the farmers, like if they sell the rice waste, such as rice husk and rice straw. So we can pay them some based on the on the weight or whatever we set for them. So actually we open a new economic sector for the farmers. Okay, and what is the relationship between in the red color ni lah? If you look at this, actually, if the best thing about the bio-waste, because it is lightweight. However, lightweight is not only good for to have a good light product, but however, when it is in a abundant, so it is bulky because it's very light. When it is bulky, in terms of to transport the bio-waste from the maybe certain area, from the paddy field, for example, to a place to process the paddy waste, the rice husk or rice straw. So it would take many lorries involved. You need to get more transportation to transport from the paddy field to the process plant. So that's why it costs it give an extra cost for us to process the bio-waste. So that how we can handle this problem, that is how we need to link with or have a good collaboration with the factories, like a paddy factory, so where actually you can have a collaboration by setting the industrial lab at the company. So all the activities, the research activities will be at the factory. You don't have to transport that into another place. Jadi, other than that, like recycling issue, even though it offers the environmental protection, such as it's reduced the open burning and then landfill. Yeah, don't be surprised that rice husk, rice waste, the first choice by farmers is to not process. The first choice that they will make it is just burn the rice straw or rice husk. So it's contribute to the climate perubahan cuaca yang tak bagus lah. So however, recycling issue will be in terms of when you use the bio-waste into a polymer, okay, you are expecting that also can be processed, reprocessed or recycled. However, recycling polymer composite is not as easy as you think, because one thing about the temperature of the bio-waste, which is lower than the polymer. So when you want to recycle the polymer, you need higher temperature. So the bio-waste inside the polymer started to degrade. So actually, what you recycle for the polymer composite is something, contribute to more problem rather than, contribute to another good product. Kenapa tak bergerak? Okay. And okay. And product on the market now that actually we use bio-waste into a polymer, and not only polymer lah. Once we process the bio-waste, this is the list of the product that actually we can have from the bio-waste. So one of that is the biodegradable polymeric system production. So biodegradable recycling, and we will see how it's work lah actually. Other than that, which is more familiar with you, is like a biofuel productions, lagi apa ya? Enzyme production, bioactive compound. So actually, all this production will produce the byproduct. The byproduct also later can be used for polymer to produce another product of polymer. Okay. So we go to the first waste. Actually, is very abundant in the world, I guess, which is all the food base actually will produce a lot of abundant bio waste. So wheat, prominence for these countries. So what they use actually for now to recycle, to utilize the wheat is to produce for bioethanol, for example. So bioethanol, for someone yang familiar with that lah kan. So I just open this slide for you, for the rest of you to know lah what's happened in the world now. What they do, what is the research activity involved in using the wheat. So one of that is the biodiesel and bioethanol. And from that process, actually, we are producing the byproduct, as I said before. So it's very, you can see that by recycle or utilize the bio waste, you can have a main product and later you can have a byproduct that, for example, is this, lignin. Lignin actually is not a main component lah in producing the fertilizer, but it can be part of the fertilizer component. Jadi instead of we just landfill it, so it's like a zero biorefinery system. So our target when we are dealing with the bio waste, we want that bio waste to be zero biorefinery system. Okay. Okay. And the second one is the rice. Okay. So here we have two. So one is for worldwide, one for the Asia. So Malaysia and Indonesia is the highest country, the percentage that produce the rice. Where is Malaysia? Here. So actually, I believe that many research has been conducted in Indonesia to utilize the bio waste. And if you look at this, don't be surprised that actually maybe you are more familiar with the rice husk, but actually by only doing research on rice husk, actually you're not you are not settled on the other part, which is rice straw, because rice straw is more produced from the rice waste rather than the rice husk. And one more thing that create more problems with the environmental, rice husk is lighter than the rice husk. And like I explained before, there's difficulties in terms of to recycle or utilize the rice straw. Okay. In the world now, okay, or for now, actually, what they use to the bio-waste later is to convert that rice husk into the biochar. Okay, so it's for the soil fertility improvement. That's why if you oftenly can see the farmer, burn the rice husk or rice straw at the paddy field like that, because actually it can give a soil fertility to the paddy field after the paddy has been harvested. So it's a natural fertility. Jadi it's reduce the cost by tabur all the baja, and other than that, the rice husk ash. Okay, RH ini rice husk ash lah. I hope you are familiar with that. So it used for the activated carbon, for the water treatment lah. And then also we extract out, we separate the black one with the silica to have a silica, whether it's an amorphous or whether it's in the crystalline. Because silica later on you can further modify it to make a fertilizer, and other than that is a carbon material. However, it's still abundant, even though all these initiatives have been come out. However, we still cannot solve the problem for the rice waste. Okay, this to show that actually what's other than just now I show you that the rice husk can turn into. So it can also use for building the material, is as a building material, such as polymer, polymer composite, bricks, and the panel, and also for the high-end material. So if you know, silica can give reinforcement to the polymeric material. So we use it as a filler to add some strength. Okay, this now we know we can have a silica after we burn the rice husk. So the ash will be separated from the silica, and silica can be further process, dilute with dilution, dissolve into to make it into fertilizer. Okay, if this picture, if you see the top one is without the fertilizer. I mean, for this case, it's using silica from rice husk, and this one with the silica from rice husk. So the paddy growth, you can see like almost double. And if you look at this picture, this is without the fertilizer. This is with fertilizer. You can see the leaf is lesser in less brownish lah compared to this the left one. How the silica contribute to the paddy growth is from the absorption of the silica lah. It's a complicated one. So here maybe I give you an idea. You can go back and study. Actually, there are a lot of things can do and can, find out to come up with a new type of fertilizer by using silica. Okay. So with that, my research with one of the local company. So we are so this company actually is their efforts lah. Me and the others, we only apply what we have doing in our lab into the paddy, because before this I use the same method to the lemongrass. We have tried it to the paddy for the rice husk lah, to later, after all, at the end it can produce the fertilizer in a liquid. So it look like a simple process, but I cannot tell you more lah. But it's possible to dilute the nanosilica with only organic acid. You don't need the mineral acid. Jadi it has a technique lah how to do. So that's why from paddy it goes to the paddy. So it gives the advantage, it gives benefits to the farmers, and then also for the paddy economy overall lah. Okay, other than that, I have explained and show you about the rice husk and what happened to the rice straw. What we can do with the rice straw. Actually, it's not that complicated things to do, but it needs a policy and act to further enhance this initiative, meaning that we have to seriously go for the biodegradable packaging. And this one has been developed by the company using the rice straw, but then also they use other bio-waste, but most of that come from the rice straw. So this is a product. There's no polymer inside. So I want to tell you that actually, even though you are in polymeric, you are a polymer expert, but you need to be, versatile. Okay, especially for those still you are going to graduate later on. You need to be versatile. One thing you have to know, what is the demand, world demand for now, what is the trend in the market, and then you need to know people around you that can help you, so you cannot work alone. So here in Malaysia, we only have 4 companies that producing 100% biodegradable packaging. So then, you can see it's not only rice straw. Any bio-waste can be treated, can be further processed to produce the biodegradable packaging. Okay, where is the polymer here? There's no polymer yet. However, okay, I use a concept. That's why I said your knowledge is, is very, it is something if you can apply into other things. Like this, I think in polymer, we know about the interlocking mechanism, which actually happen in rubber, kan? If carbon black as a filler in rubber, when we process that, it will give we call it interlocking mechanism. So in this case, what I try to, apply the theory is by this, we call it a binding mechanism. Okay, when you treat the rice straw, so this material, in this packaging product, it needs a binder. So this is the binder. Jadi when this binder goes into the hole between the cellulose, when you imagine that you have like a fiber mat. Fiber mat. So it has a gap between the fibers. So between the single fibers, so it needs to be filled up with the binder. So before this, the people using binder from starch. Okay. So now, because this binder, when it has the similarities in terms of surface roughness and hydrophilicity, so here you can have that the binding mechanism. Okay. Okay, other than that, so we come to the number 3 punya, the bigger or the highest biowaste lah in Malaysia or in Asia or in the world. One of that is the oil palm. And we know that oil palm, Malaysia is the highest oil production from oil palm lah. I think I agree with that. But however, what we can use the waste from the oil palm for now, because oil palm, it has the waste, it comes from the crude palm kernel oil and palm kernel cake. So the beautiful things about this, all the oil palm waste, it has an oil inside. Even though it's been pricing 100%, the cellulose in the cellulose still have the oil, so it's still oily. So what is the good thing about to have this oil? Jadi that's why oil palm is the most suitable process is to produce the biodiesel. Hopefully we can use the biodiesel soon lah. So actually this process has been it's already has an established process, and yeah, it's just a matter of time lah to be launched. Okay, when you process the biodiesel, when you process the oil palm to produce the biodiesel, as like a wheat waste before, it has a byproduct. So the byproduct here is using, it can be used for this, for energy lah. Jadi it is again is a zero biorefinery system. And later is not only glycerol, it has another like in the solid, okay, such as the waste from the cellulose, the byproduct in the cellulose type. Okay, so now we are at this segment, I call it segment, which is polymer product. Jadi, we have bio waste. We have polymer composite at our left and biopolymer at our right side. Okay, you must understand these two is different. One can be 100%, the biopolymer is 100% biodegradable, I mean 100% compostable. However, polymer composite, if the matrix is not the natural polymer, so it cannot be 100% biodegradable. So that's why we call it composite. Okay, don't get confused with that. And we come back again with the oil palm. As I explained before, oil palm, it has oil. So what is so good about this oil in the oil palm waste? So you can straight away use the waste from the oil palm to produce biopolymer, where actually we call it PHA, polyhydroxyl alkanates. Senang, it's easy to call it PHA lah. So PHA ni, I think everyone knows that is good for biodegradation, biodegradable product, especially for high-end products such as for medical application. So this, if you can see, It can use for antibacteria and even for like a memory enhancer. Don't be surprised. So the PHA can offer all these applications. Okay. Other than PHA, we have PLA, where actually is a come from the starch-based material lah. Okay. So here PLA, PHA, and we know that both have a different carbon. Jadi for polymer people polymer student, you must know these two different. Okay. However, to get short, PLA has lower strength, for example, lower strength than the PHA for a certain reason. So this lecture cannot cover everything lah. We need another session. So these two biopolymer can produce not only for medical, but it can produce this, the real biopolymer product lah in the market. It can be as a main main matrix to produce this, or as a filler. Filler is a cheapener lah after all. However, I put here bioplastic food source versus biowaste. Okay, this one, we know all palm is the biowaste. However, the sugar beets, corn, and other type of starch-based source actually is a food source. So when we use the food source as a raw material to produce the bioplastic, so there's a we call it a food crisis here. So people needs food for their to survive, but why we need the food source also to produce the bioplastic? So now that's why where the bio waste should be championed in. I mean, you should fully utilize the bio waste to produce bioplastic. Okay. Now we are at the polymer composite. Okay, where actually it cannot be 100% biodegradable, but it can be recyclable. So put aside lah whether it is difficult or not difficult, but it still can be recycled. It is an MDF panel. Okay, it use the rice straw. Nice, huh? However, in Malaysia, Malaysia or even Asia researcher, we have done a lot of research on all this bio waste. However, we cannot really apply it in our own country because of the weather factor. When I went to my visits to United States, actually you can see the panels made from this biocomposite. It's very wonderful. And don't be surprised that now we have a biological house. Okay, it made from the this bio waste it's a wheat waste. So it's combined with the polymer, and then it turns into the house. It's not the panel. How beautiful it is. And we have a nanocellulose vehicles. Even it's a concept car, but again, it shows that everything is possible to convert the bio waste into something like this high-end product. Okay. Okay. So not everything that I showed you just now is my works. Okay. So now I like to share some of my works during my my life journey as a academician and researchers. So this all the bio waste that I work with not only myself and with my team and my students. It looks many kan, tapi biasalah, it's for 11 years kan. Every year we come up with a new, that's why as a researchers, you can always come up with your own idea and after look at the what's going on in the world. Most important is about the demand, world demand. Okay, one of them is a tapioca waste lah that I could be proud of lah. It's contribute to some of my achievement. How I come up with this? Actually, I have read from the one books and the journal is a lot in Indonesia. Indonesia plants 1,000 acres, maybe I'm not remember, of tapioca. But it just the waste, nothing, you don't do anything with the waste. So I did some research and then actually, at a reasonable amount, there's a low molecular weight of the latex inside the tapioca tree in dia punya batang or even in dia punya daun, but more on batang lah. Okay. Okay, so we did some studies on the characterization. It's not completed yet. However, it's proof that, other than the hevia, rubber, we can have a lot of the natural latex from other resources. Okay, I use that the latex, okay, the natural latex from tapioca, not as a main material to produce glove, for example, but I use it as a part of, as a filler. So yeah, looks so good, but however, I'm facing the problem in terms of the locality. Malaysia is no longer like planting the tapioca. Before that, we have one in Perlis, where am I now lah? So it's been closed. So I have to stop for now. Maybe I need to find someone in Indonesia, and we can start all over again this project. Okay, and don't be surprised that the durian also can be, turned into valuable polymeric material, and it has been studied and it has been all the filing pattern, everything has been done. So I started with this, producing again the biodegradable packaging product and plastic film and bottles. And even now we are working with the biopolymer. Okay, so it's abundant. Don't be surprised. Malaysia has a lot of durian waste. Other than that, the lemongrass looks like, where I get a lot of lemongrass. Yeah, it is there. You can have it as long as you have an effort to get it. So what is so special about lemongrass? Logically, sometimes you cut the lemongrass kan, and then your finger, skip, you might cut your fingers lah a little bit kan. So because the grass, dia punya daun tu is very sharp. When it is sharp, it has something like a hard material, and when I find out it's because of the silica. So it's been studied and then we modified the process. You cannot just apply the extraction like that, and we have modified that until the end we get the high crystalline silica, which is like 92%. Okay, so if you can see, dia punya crystallinity index 92, which is not as good as a silica sand lah, but it's 92, is considered high. So that our method, by extracting the silica, we apply for the rice husk, because we don't use the same method that people use to extract the silica from rice husk. So we have our own method. Okay, this is actually my PhD project. However, I upgraded that into make some things can be to produce valuable material. For this one, making the polymer packaging, foam lah, dia macam foam. Kalau if you buy the computer, you can see the forming materials kan for your packaging tu. One is a polystyrene, and now actually people turn to the cardboard kan. Sometimes they don't use the polystyrene anymore because there's an issue with the PS. And my project here, we use recycled newspaper, PP and NR, where actually it's look like impossible to do because this too is hard to blow. Okay, I mean to get the foam. However, at certain level, we manage to have this, beautiful one. I mean, here, this is the cells. This is the closed cell. Okay, in foam we have closed cell and open cell. But closed cell is good for the high-end product. Okay, but it's hard if the open cell is for the sponge kan, and then macam tilam, your mattress is an open cell, and this is a closed cell. Okay, after recycle newspaper, we turn to the coconut waste. Okay, coconut waste, I look at the coconut waste, it's not just like put it that way and then press like that. So we have fabricate that into honeycomb. Okay, we managed to get until the end, until kata sampai at this stage lah. However, to fabricate that in a larger size, it needs bigger mold. However, it proved that it can be done and beautifully, produce this. This is a concept, our bumper lah. Okay. Okay, so it suitable to be used as a bumper materials. Mean your bumper now is only flat, okay, only a sheet of plastic composite. But actually, it can be more than that. You can have a structure like a honeycomb. So using such as this. Okay, you can see here, this before the hydrolysis. Of the hydrolysis, it have a surface roughness. So the surface roughness, when you put it in the polymer material, again, it has an interlocking mechanism. The binding mechanism is there. Okay. However, when you're dealing with something like automotive product, high-end or intermediate product, so you cannot run from, we call it a product design. You must consider the product design criteria. It is the three most important elements lah in design the bumper beam, okay, material. So it will be in my books later lah. Later, if the books is released, my honor to share with you. Okay, this is another foam. However, we are using sodium bicarbonate. Even though it's not the Biowaste, however, it's a common sodium that bake the cake. Okay, so we don't want the sodium bicarbonate that used from the industrial because it has adalah side effect there. So we use that one in the natural rubber. And then we got this quite regular form of the dia punya cell structure. Okay. And for other than the Biowaste that I displayed before, my students also studied on the cocoa pot husk. This paper, one of the highly cited paper lah. I think on the single paper pun almost 100 lah cited this. So the potential is there. Okay, and one more is the coconut shell powder. So this is some of the two papers that under my our publication, me and my students. Okay, so after everything, you tengok, it's so good lah. The Biowaste can produce biopolymer, can produce biocomposite. However, remember that I said we have one big issue, which is on recycling issues. Okay, that is okay if you claim that bio waste, when after we add into the polymer, it can be recycled. However, or even biodegradable, you must understand these three terms. Okay, one compostable, one degradable, and one is 100% synthetic plastic. So degradable is not 100% biodegradation, where it can be almost 100%, but as long as it's not, but it still have this microplastic, it's not fall under the compostable material. So this is serious for the one single-use plastic, such as plastic bags. So it must be 100% compostable. However, for the polymer composite, such as bumper, and even for housing, we don't facing the issue in 1 or 2 years or short term. We will face the problem for like 50 or 100 years after, because when you build the polymer composite, for example, for the house, it must be able to stand, the condition of the house must be stand for at least 50 years and even for 100 years. But then again, what we are going to use with the scraps from the bio-waste composite, there is still room to do more studies on that, even to convert that into another new product, or again, maybe for the middle stream product, downstream or middle stream product. Okay, some of the reference from the presentation. Okay, with that, I'd like to end my presentation, my sharings lah. It's not so academics in terms of, I believe that all the students and all of the participants today, you know more lah about the, for example, the filler characterization, whatever compatibility, I don't have to mention, but I want to open everyone's, everyone, what actually there are a lot of things we can do in the world with the bio waste. So for further information, you may contact me through my email, or even WhatsApp me. I think I'm okay with with texting, and then you can go into my publications later through my all these scholars account. But I don't update on my Scholar Google lah. Don't go to Scholar Google. I don't always believe on that. If you want to promote your things, you can use Scholar lah, Scholar Google. But I prefer this one, Scopus. Or you can interact in the ResearchGate. Okay, but this is the most fastest lah, SMS or email. Okay. With that, thanks again. I'd like to say thank you, million thanks to ITS who invited me for this session, and then again to Ibu, Miss Desy, Amaliya, your hospitality is superb. Okay, so then I end my presentation. Thank you.
Okay, thank you very much, Professor Hakimah Osman. If I may say, it's a marvelous what you did on your research.
Thank you.
Because
Thank you.
you try to increase the utilization of waste, become a valuable product.
But I quite rush. It's rushing session lah. It's only 50 minutes, so it's like an opening. If later like you want to know more, yeah, it's open for discussion. We can have another session. It's open. It's open eyes punya session lah. This one.
Yeah, okay. But I think it's a very interesting and very useful. You're sharing knowledge. Maybe we can have some research collaboration further with the Department of Materials and Metallurgical Engineering.
Yeah, should be, inshallah.
Yeah,
So,
inshallah. Before we start to question and answer session, maybe I would like to say hello to Dr. Hosta. Maybe you will be so happy to meet with him, Dr. Hosta.
where are you, Doctor?
Dr. Hosta, are you there? He's here. I see his name, Dr. Hosta.
Dr. Hosta, he used to be my lab mate lah. So we are under the same supervisor, Prof. Hanafi. So I am surprised when Bu Amaliya told me just now that Dr. Hosta is at ITS. Oh, okay. Yeah. But yeah, it's a small world lah.
Yeah, okay. Maybe Dr. Hosta still did another job. Okay, so I am actually curious because you did a lot of research and you tried to looking for a natural resource. You try to looking for the waste, especially bio-waste, to produce a valuable product. So how long your research takes until you get the product normally?
Okay. Look at that one. I'll give you one example. Okay, like a durian, people,
Yes.
I can say like, okay, that's why you must believe in whatever you do. One thing is, for example, durian. People laugh at me when when I come out with my first idea, biocomposite from durian. Okay, because durian is a seasonal fruit. Again, okay, it's seasonal, but then is high demand right now. But with a strategic planning, with whatever we do, research, actually, it can be, it can be secured. Throughout the year. How? That's a secret. But I say, what?
I mean, how long?
No, yes, that's right. I started that in 2009.
Wow.
So it's still being carried out until now.
Okay.
So for everyone's just it is my view of point lah.
Yeah, now we have Dr. Hosta.
Halo.
Dr. Hosta.
Assalamualaikum. Ya.
Waalaikumsalam. Apa kabar?
Apa kabar baik ya, Doktor?
Alhamdulillah kabar baik.
Ya.
Terima kasih sudah bersedia share knowledge ke kami.
Yeah, my pleasure. We can have more than after this.
Of course. Sure. Yes, we are pleasure to conduct any.
And then yes, this is open for, I think I have colleagues also not from UniMAP, is from other institution. So they are listening now. So you are actually been promoting. Yes, they like to hear lah, to know not only me, not only what I'm doing now, but they actually about ITS.
Oh, okay, I see. Thank you. Okay, I think we can start to the question and answer session, Professor Hakimah.
Yes.
Okay. Falki Yusuf, I think you may deliver your question directly to the Prof. Hakimah. Falki Yusuf, would you mind to deliver directly your question? Oh, okay. Okay. So I think I can help to read the question. Good afternoon, ma'am. My name is Yusuf. I would like to ask question. What are the consideration of choosing biowaste that can be used as a polymer material product? Thank you. So he is asking what are the consideration of choosing biowaste that can be used as a polymer product?
Okay. If I may share the screen again. Why? That's in my slide. Actually, okay, the consideration. Where is the? Okay. Okay, it is here. Okay, the criteria that actually you need for, when considering any bio-waste. Okay, the most important, like I said, is the accessibility. Because the accessibility means if you are talking about commercialization or even pre-com, in industry, they're expecting that it's not like 100 kg is a ton. It can be 100 tons, 1,000 tons, something like that. So the accessibility, how abundant it is, there is very related to each other. Sometimes it is abundant. However, the accessibility, how to access that things is difficult. For example, your institution, okay, at the north, okay, and then that bio-waste were actually abundant at the south area where maybe it takes like about 100 kilometers away. So, the journey, to transport your bio-waste to your lab, research lab, kan? It takes maybe by posting or even transportation, it is costly. So the consideration, the most important consideration is that. So other than that, what I stated here lah, because it's related to each other. When you are able to to produce product bio-waste, product from bio-waste in a mass scale, mass production. So actually, it will contribute to the it will contribute to the society, to the industry, to the nation, and even if we're talking about academics, it can be able to be published at high impact paper, can produce postgraduate students, can get research grants and many others. Because all the bio waste has the same characteristic, like weights, and then certain and then is a hydrophilic. But this one, so please take note on these things. Okay.
Okay. Okay, okay. And then the second question is from Rizaldo Rizky Himawansyah. Rizaldo, do you want to deliver your question directly? Rizaldo? Rizaldo Rizky Himawansyah?
Yes, ma'am.
Yeah, okay. You may deliver your question directly.
Actually, I forgot the details, but what I'm asking is, I ever hear that when we recycle material, there will degradation of the properties. Like, for example, when we recycle a plastic bottle, there will be the strength will be reduced when we recycle it. Oh, sorry, I can't turn off my video because some problem in my camera. So what I'm asking is this kind of thing also happen in the biodegradable, I mean bio-waste recycled product? Is there are the property is not as strong as from pallets, plastic pallets like that? Thank you.
Okay. Okay. So to answer that, okay, if you remember that bio-waste can turn into biopolymer and biocomposite. Okay, so biopolymer, you must understand, it means to be degrade. So there's no point to recycle. Okay, so it means to be degrade. Mean we want that to be composed. So nothing left after. But it's good for certain reason. For example, for implant. So implant, when it is degrade, you don't need to have a post surgery after that. Kan? You don't need a post surgery. So your bone can be rehealed, healed. Okay. So if you use the steel to heal your bones, the cracked bones, fractured bone, you need to do a post surgery. So with the biopolymer, you don't need that. That's why it means to be biodegrade. However, for polymer composite, again, there is an issue that cannot be handled, where actually the issue is same as for other polymer composite. So even it's become more serious because, as we know, bio-waste, it cannot stand high temperature. Even though like rice husk rice husk too can be one of the bio-waste that you burn that it still have something inside. That something inside is a silica. It's not the black one, the ash will be used for other things. So here, say, take a look at the same example. Can you imagine that your bio-waste, you add into, for example, PP, PP, and then you want to recycle the PP at temperature of 180. Okay, 180, but 180 can consider low. And however, when the cycling is repeated, the cellulose by the bio-waste will be degraded. So means it can be, what I can answer here, it can be used, still recycle, maybe one or twice. However, it needs to be further characterized because of it is organic then. Organic, it will degrade. So again, cannot be used for maybe for the same purpose. For example, for the first stage, maybe it used for the water bottle. But later, when you recycle, you cannot use for the same for the same bottles. Maybe lower grade than the bottles. Okay, I think that's I already answer your question. Again, your name?
Rizal too, ma'am.
Yeah, Mr. Rizal. Am I answer your question?
Yes, thank you.
Yeah, welcome.
Yeah, okay, thank you. And then the next question is come from Rahardian Mahendra from Materials Engineering Department. Rahardian, would you please to deliver your question directly, Rahardian?
Yes, ma'am.
Yeah, okay.
First of all, thank you. It is great presentation from Professor Hakimah. Secondly, I'm sorry that I cannot turn on my video because I'm not using my laptop, I'm using computer. So my question is why this kind of invention has not applied globally, because I think it is quite safe for human life. So why it has not applied globally? And the second one is uh, if it gets into human body or animal, is it safe? Thank you.
Okay, thank you for the question. Okay, for the question number one, okay, from the long list of my presentation, for now only one that I can say successful to be commercialized, but it's not on the it is with the collaboration with the company, which is with the rice straw and the durian waste also. So before this, if you still remember in my presentation for the biodegradable packaging, okay, the company has has produced that biodegradable packaging for local and for export. Okay, I mean for the outside Malaysia. So because one thing, biodegradable packaging, that one is 100% compostable, is straightforward application, and there is no issue on the biodegradation, because when you enter the countries such as Europe, there's a standard that you must comply. So if your things that not really biodegrade, for example, if your product is a biodegradable product, so means it's not allowed into the market. So for other product, okay, to be commercialized, again, maybe I can share one thing. You need to have a serious industrial partner, okay, to join or to that you can we call it have a joint venture to commercialize your research idea. That's the most important, because one thing to build a new factory alone to produce your own research, it takes millions. So like the risiko is there, the money is there, and one thing, the background of the business is not there, because myself, I'm an academician. So now the best way to commercialize your things, your research product, is by joint venture with the industry. Okay, doa for me that I will be more successful in the future. Okay, to answer the second question, yeah, when it enter into the human body, okay, you must think two different things. One is a biopolymer, okay, where actually it means to be biodegraded, and number two is again, if you take it directly, the bio waste, even though before or after process, it depends on how you treat the fiber. But we don't like simply, we cannot use biocomposite, for our tissue engineering or for implant, because it's not, unless your matrix is a biopolymer. Okay, so any bio waste that is safe to be used, means safe here, it should not use any chemical for treatment, kan, especially the mineral acid or whatever chemical yang hazardous, kan, ada listed in the international listed punya chemical, so it's free to use, because fiber, yalah, the bio waste means to be treated before use. And what things used to treat that, that's the most important. You have to come, we call it a green solution lah. Green chemical, green solvent, all greens. Then only you can pass all the testing procedure on the medical especially. Okay, I hope that your question has been answered.
Thank you.
Yeah, is it clear?
Clear. Thank you. It is great explanation.
So Bu Amaliya, don't worry, I'm not in rushing, because now it is over the office hour, so we can have, it's my honor lah to spend time and to answer any question from the student or from the lecturer maybe.
Yeah. Okay. Thank you, Professor Uma. So I see in your set also Silkro. Silkro is also one of the product of your teams, Paddy to Paddy.
Paddy to Paddy. That's interesting.
It's also one of your product. One of your team project.
Yeah, it's we call it a transfer knowledge. There is a transfer knowledge from university to industry. So the product is sold by the company. So what I have for now, I have transferred the knowledge from my student. Okay, what's the beautiful things about this one? That is how things works together. Okay, my students, my PhD student who graduated in 2019, and before Enhance, actually, she worked with me and the company to develop this baja, this fertilizer. So after she's graduated, she worked with the company and she hold all the the process, and until the end is come up with the final baja, the final fertilizer. So yeah, part of it, I can say I'm proud of what she has now. I mean, the transfer knowledge is there. The transfer knowledge is achieved. That's the most important.
Yeah, this is very interesting because you try to utilize the waste from the paddy and then you use it for paddy also. So it's very interesting.
Yeah, because fertilizer before this, it can be found as silica in solution. However, it must undergo the process using the mineral acid, and then with longer process where actually take longer time, more acidic, and then of course the cost will be higher lah later. But from what she studied in her PhD, so we modified that. So we managed to cut down some of the process using not the mineral acid, but the organic acid. That's why, again, now people are looking at the green solution, green solvent. Yeah. So you guys also, or every one of you must think about that lah in your future research.
Yeah. Okay. Thank you. Unfortunately, actually, we would like to have a longer discussion, but we have a limited time. So maybe we can discuss further in the other occasion, and we are looking forward for the further collaboration, Professor Hakimah.
Inshallah, yes.
Inshallah.
Maybe we can after this we can have a meeting
Yes,
among the staff.
Yes.
So we can find there's a lot of grant, international grant, Asian grant. I'm not sure, but for the